Let's discuss how to select lithium-ion cells for Pichondria and also its installation. Look for data sheets of the lithium-ion cells that you are planning to use, and check if they meet the following criteria discussed. You will have to look for the charging rates, discharging rates, size of the cell, C rates and cell capacities. We will now discuss them in detail. First, let us check for the size of the lithium-ion cells. The compatible size of the cells, which can be installed in Pichondria, is 18650. These cells have 18 mm diameter and 65 mm length. If you have cells of other sizes, you can solder them with a wire on the soldering pads on the Pichondria. The lithium-ion cells have charging rates that are recommended for them. There will be a standard or recommended charging rate, and a fast charging rate mentioned. The standard rate is the recommended rate of charging, and the fast rate is the maximum recommended rate of charging. It is advisable to charge at lower charging speed, for safety and life of the lithium-ion cells. Let's take a look at how to calculate the maximum charging rate and the recommended charging rate. When two cells are installed in parallel in Pichondria, the charging current ceilings can be multiplied by the number of the cells, that is 2. For instance, if the fast charging rate is 5000 mA and standard charging rate is 1000 mA, and if you are installing two cells in Pichondria device, the overall fast charging rate can be up to 10 amperes and standard charging rate can be up to 2 ampere. But Pichondria has a charging rate limit of 1 ampere in its hardware. Now that we have calculated the maximum rates that can be used, and the hardware limitations of Pichondria, let us see which rates to use in Pichondria for better performance. When an adapter is plugged in, and is supplying current to Pichondria, Pichondria will charge the installed lithium-ion batteries, and simultaneously power the Raspberry Pi. The Raspberry Pi is powered from the adapter current. Batteries are charged until they are full. Once the charging is complete, they are used to power the Raspberry Pi only when the adapter is disconnected. Unlike some UPS which uses a high-speed charger to charge the batteries, and power the output from these batteries, Pichondria powers the Raspberry Pi directly from the adapter and only uses the cells when adapter is absent. Let's take a look at the charging currents. When a high charging current is used, the charging time is shorter. Since a high current has to pass to the cells, the heat generation would relatively be higher. The adapter will be powering both the Raspberry Pi and the charging circuit simultaneously. When a high current of charging is used, it would be necessary to use a higher wattage adapter at 5 volts. Since most adapters do not supply very high current at 5 volts, when a higher current of charging is used, and when Raspberry Pi draws high current, the adapter would experience an overload. Some adapters tend to lower voltage or some shut down when this happens. The batteries would discharge when the adapter turns off momentarily, multiple times. When a lower current is used for charging, though the charging time will be longer, the cells experience very negligible heating. This also helps cells to attain a higher capacity, and also prevents overloading of the adapter. As the charger IC takes very less current, the adapter which you are using for the Raspberry Pi would normally work well. So, this is the recommended mode of usage. Unless the device is located at areas of frequent power outages, a low charging rate is the preferred mode. The lithium-ion cells have a maximum current or rate at which they are designed to be discharged. There are usually two rates mentioned, a recommended standard discharge rate and a fast discharge rate. Standard rate is the maximum recommended rate to discharge for the life of the cell, and fast discharge rate is the maximum rate of discharge for the cells. Let's learn to calculate the discharge current that the cells would be exposed to. If the cells are discharged to 3.4 volts, which serves as the set shutdown voltage of Pichondria, and if 3 ampere is used by the Raspberry Pi, and Pichondria is working at 85% efficiency, we can observe that the cells can discharge at a maximum rate of 6 ampere in this condition. The protection circuit of Pichondria is designed to withstand up to 7 ampere of current, beyond which, it will cut off the power to protect the lithium-ion cells. As a rule of thumb, it is recommended to have cells of discharge current of 7 ampere or better, for Pichondria. The cells also come with a parameter called cutoff voltage, which serves as the minimum voltage to which the cells should be discharged to. Pichondria comes with built-in protection to protect cells at 2.8 volts. So, it is recommended to use cells with 2.8 volts or lower discharge voltages. The Pichondria charger is specifically engineered to charge lithium-ion cells. It is designed for use with widely available lithium-ion cells that have a maximum charging voltage of 4.2 volts. The C rate of lithium-ion cells is a measure of the rate at which they can be charged or discharged relative to their capacity. It is expressed as a multiple of the cell's capacity. For instance, if a 2500 mAh lithium-ion cell is rated 1C for discharge, it means that the cell can be discharged at a maximum of 1 times 2500 mAh. If it is rated for 2C, it can be discharged at maximum of 2 times 2500 mAh, that is, 5000 mAh. Sometimes, the charge and discharge rates are mentioned in C rate in the datasheet. A higher C-rated cell can discharge or charge at higher rates, compatitively. Let's now take a look at how to install the lithium-ion batteries once you have chosen the cells to be installed. Firstly, it's important to ensure that the cells to be installed have the same voltage. Pichondria can function with a single lithium-ion cell if it can supply sufficient current, however, using 2 cells is recommended to reduce stress on them. When installed in Pichondria, the terminals of the cells in the slots are connected together, essentially placing the cells in parallel. It is crucial that the cells have similar voltages, as connecting cells of different voltages may result in unsafe conditions. Without significant resistance between the cells, the one with a higher voltage could discharge with a very high current, causing excessive heating. Simultaneously, the lower voltage cell might experience a charging-like incident with a very high charging current, posing a safety risk. Therefore, it is advised to confirm that the cells have similar voltages before installation. The cells in Pichondria are arranged in parallel, ensuring that the positive, plus, side of both cells aligns. The polarities are clearly indicated on the printed circuit board. It's crucial to verify and match the polarities when inserting the cells during installation. Let's see the installation of cells in action. First, let's ensure that the lithium-ion cells have similar voltages, and also check for their polarities. Usually, the negative terminal will have a relatively larger area of contact. Once we have ensured that the cells have a similar voltage, insert them on the Pichondria board, ensuring that the polarities match correctly, as indicated on the printed circuit board. After installing the batteries, let's ensure that the Pichondria is functioning properly with them. Initially, unlock the Pichondria's battery management system by connecting the adapter to the input. Subsequently, attempt to power on the Pichondria by pressing the switch once. Confirm the functionality by observing the LED on the Pichondria, which should illuminate upon pressing the button. Next, verify if the Pichondria operates effectively on the installed lithium-ion batteries by disconnecting the adapter. The Pichondria should remain operational even after removing the adapter. To power off the Pichondria, press the switch once, and then proceed with mounting the Raspberry Pi on the Pichondria. The LED indications will be discussed in another video. The battery installation is now complete. Let's proceed with mounting the Raspberry Pi on the Pichondria to make it a fully functional system.